So last class, we used the endogenous growth model. This model was used to understand the income disparity among countries, like why countries grow faster than the other. So this is a big improvement over the solo growth model, because in the solo growth model, there's no long-term economic growth. You have to rely on some exogenous technology progress to generate long-term growth. And then, so in the endogenous growth model, we endogenize the technology progress by considering human capital. So that was explained to the phenomena why some country enjoy higher growth rate over long term than the other. In today's class, we are going to move to a new chapter. In chapter 9, we are going to study consumers' consumption and saving decision. This model is going to use to understand how consumers are going to respond to changes in income and interest rate. And then in the next class, we are going to study how consumers are going to respond to change in tax policy or government spending. So before I start, I want to highlight, so this is a two-period model. This is different from the earlier model we have studied. So remember, earlier we have a one-period model, static model. In there, we study the consumer consumption and the labor leisure choice. Okay? And then there was no saving decision, because you only stay in the economy for one period. There's no point for you to save. Right? But now here we are going to study the consumer's consumption and the saving decision. Right. So this is a question we can ask or we can answer at the end of this chapter. Right. So for example, so we are going to see how government budget deficit is going to affect how consumers' consumption saving decision. Right. All right. So let's start with consumption, or why we care about consumption. Right, or why this chapter is about consumption and saving decision. So this is the equation we are very familiar with. Right, what it is, this is the total GDP on the left-hand side, and on the right-hand side, we have 4 categories of expenditure. This is including consumption, investment, government spending, and the net export. If we look at the data, consumption accounts for more than 2/3 of the total GDP. So this is true not only for US, this is pretty much the facts for all the country around the world. Right. But now we need to understand what economic factors determine consumers' consumption and saving decision. The answer to these questions, or in other words, what determines C versus saving, right? As you're going to see later, saving here essentially is going to equal to I. Okay, depending on what model you're going to use, right? But they have a very close relationship, or roughly speaking, they are the same. The answer to these questions is going to help us understand the following key issues. Right? Number 1, what determines government debt and the deficit? Number 2, if there's some financial market imperfection, how would that affect consumers' behavior? Or in other words, so what is going to cause a financial crisis, right? So, but this is going to rely on this model. Number 3, we are going to use this model to understand the social security. So why we need the social security? What's the benefit of introducing this social security to our economy, right? All right. For the moment, what we know is that in the solo growth model, oh, by the way, this is a typo, okay? So in the solo growth model, we have is C, so in the solo model actually is saving equal to is times Y. That just implies C equal to 1 minus is of Y. Right. As you can see from here, your saving and your consumption are given. I mean, the amount is given. So once you know the total output, and then you're going to know how much you're going to save, how much you're going to consume. So those are exactly given. But the question is, where does it come from? Okay. Why don't households optimize? Meaning, so why don't households choose something is best for them? Right. But then, so in these chapters, we're going to answer these questions. If you allow the consumer or you allow the households to optimize, to choose the best for them. What will they do? Right. Now, so in the following slide, you're going to see with household optimization, expectation is going to matter, right? So what is expectation? Essentially, expectation regarding to like future price, expectation regarding to future policy. Number one. Number two, there's going to be the distinction between current and permanent income. Like if you have a temporary or current income increase versus you have a permanent income increase, its impact on your consumption and saving behavior is going to be different. And the third, the real interest rate is a key variable. So actually, real interest rate actually is going to tell you the relative price of consumption today versus consumption tomorrow or in the future. Okay? So this is what we're going to study. Now, in the previous model, like I said earlier, right? So we have studied consumption and the leisure, but the model essentially is static in the sense there's no today or tomorrow, so there's no future. That's you only cares about current. So it's like static model. But however, so in reality, life is full of intertemporal choice. Intertemporal meaning, so there's a choice between current and the future. Here are two examples. Should I go to college or start working immediately? Should I save or should I consume now? Right? Let's start with the second one. If I save today, that's going to affect my consumption today. So the more I save, let me write down, the more I save, and usually means the less I'm going to consume today. Right? But that's going to lead to more income in the future because you have saving income in future. It's going to increase. And at the same time, your potential consumption is going to increase in the future. Right? So it's clearly you can see, so there's a trade-off between today's consumption versus future consumption. And similarly here, should I go to college or start working immediately? If I work immediately and then similarly your income today is going to increase. Right? If you work immediately. But now in the future, so your income is going to stay there because you don't have good education. On the other hand, so if you go to college, your current income is going to drop. Actually, you probably is going to lose most of your income because you cannot work. But then, so your future income is going to increase because you earn a degree, right? So you're going to have a better job. So clearly you can see there's a trade-off between today and tomorrow, or current and in the future. So this is what we mean intertemporal. Right? All right, so now let's look at the model. Okay, so in this model, we have representative households. So what is representative means? This means everyone the same. So this is a simplification. Okay. Each household is going to live for 2 periods. Okay. Today is labeled as period 1, and the future or tomorrow is labeled as period 2. Okay. But 2 is a good simplification, right? So once we understand today and tomorrow, right? So essentially we understand current and future because everything can be fit into this framework. Because this is a simple abstraction. Okay. So households is going to receive exogenously some income. They're going to receive income Y in the first period. They're going to receive income Y prime in the second period. Right? But here we just simplify or we just abstract away from the labor leisure choice, like we discussed earlier. But clearly we can incorporate the labor leisure choice into this framework. Right? Now, similarly, so you have a utility function. Remember, so when we talk about labor supply decision in the earlier chapter, the household's utility is coming from C versus L, leisure. Right? Now here, instead from leisure, the household is going to develop utility from C and C prime. What is C? C is the current period consumption. Okay? And the C prime is a consumption in second period or in future period. Right? So it's care about today and tomorrow. Regarding to the preference, or in other words, the U, C and the C prime. So this is a preference, right? So how you rank how you rank all possible consumption bundles, right? So different quantity. Regarding to the preference, there are following assumptions or there are following properties. Number one, monotonicity. More is always preferred to less. Right? So this is essentially coming from the observation of the human behavior, right? So you always prefer more versus less. Number two, you have preference for diversity, right? This is also called consumption smoothing. And then what does diversity means? Here you have two different goods, today and tomorrow. So it's better to understand today's consumption and tomorrow's consumption as two different goods. Okay? So you have preferences of diversity means you care. Say for example, you have two possibility, right? You have a lot of C, but you have very little C prime versus C and C prime, they are pretty much the same or very close. And clearly you are going to prefer this one. Right? So you have different things instead of you have a lot of first one. Right? So this is what I mean diversity. And this also means consumption smoothing. That just means so it cares about the relatively speaking, the similar amount between C and C prime. This is like smooth your C and C prime, smooth your current and future consumption. Now the third one, assume current consumption and future consumption are normal goods. What does normal goods means? Means your income increase. Your income increase usually leads to C and C prime, both are increased. This is normal goods. Okay. So what is opposite to normal goods? It's inferior goods. So what is inferior goods? Inferior goods says if your income increase, your consumption usually is going to decline. So this is inferior goods. All right. Now let's look at this indifferent curve. Okay. So what is the indifference curve? The indifferent curve have C on the horizontal line. This is the current consumption. And C prime, which is future consumption, on the vertical line. And the indifferent curve is going to provide a level of happiness or level of well-being for different composition of C and C prime. Like say them in this curve, I1, along this curve, you're going to derive the same level of well-being or happiness or preference or utility. Okay? But along this line, you have different combination of C and C prime. Like say them B versus A. Okay. So on the B, so you have more of C prime, but less C. And A, you have more C and less C prime. All right. So this is the indifference curve. Now let's just see so why the indifference curve look like as it is. Okay. This actually follow from the three assumptions we have just discussed. Okay, let me erase this and then explain to you one by one. Start with the first one. The indifference curve is downward slope. And why it is a downward slope? This is coming from the facts in the previous slides. More is always preferred to less. Now let's see what happened. So you start with B. Okay. If you decrease my C prime, okay, because more is always preferred to less. If you want to keep me in the same level, remember this I, it is the level of utility. If you want to keep me in the same level, more is preferred less. Because I lose C prime. In order to keep me the same level of happiness or utility, you must give me more C so that I can be compensated. So that's why, so that means the only direction you're going to work is goes to here or goes to this direction. That's the only possible direction. First, you go down, and then so in order to make sure I have the same level of utility, it must go to this direction. These two combination means first go down and then go to the right. So that just means only possible direction to go in terms of indifference curve is goes to this direction. So that just means so this is a downward slope. This downward slope. Okay, this is number one. So more is preferred less, leads to a downward slope indifference curve. Number two, this curve is convex, meaning the slope is getting smaller and smaller. Okay, so when you start at B, your slope is very steep. Okay, compared with A. By the way, here we talk about the absolute value of the slope. Right, this is a negative. Here was steeper, so that just means that the absolute value is higher compared to A. Okay. But in order to help you to understand, so why this is these measures more diversity. So we need to introduce the concept of marginal rate of substitution. That's on the right hand side, marginal rate of substitution. So this is a marginal rate of substitution C over C prime. This just means this is measuring at which rate you're willing to give up 1 unit C. So that's going to equivalent to MRS unit of C prime. Like here, if you want me to give up 1 unit C, okay, and then the slope tells you, so you need to give me a lot of C prime. You need to give me a lot of C prime. Or in other words, so I'm willing to give up a lot of C prime to get 1 unit of C. Okay, let me write down here. Here, in order to get C, willing to give up R is C and C prime. We can just put some numbers. Say, for example, this is like 3, right? Give up 3 C prime. Now here, so this is going to very flat. Okay, so in order to get C, we need to give up maybe like 1 unit of C prime or even less, 0.5. Okay? And that's how we understand the difference. So here, this means you are really cares about C compared to here, right? Because here you're willing to give at point B, you're willing to give up 3 units of C prime to get 1 unit of C. But now here, you're only willing to give up 0.5 unit of C prime to get C. And clearly, so B compared to A, the B you cares about C more than A. And why is that? Is because so at B, you already have lots of C prime. You have very little C. You desperately need a C. But at the A, so you have a lot of C. You have a lot of C. But you have very little C prime. Now, it's in some sense, you don't care about C, but you really care about C prime. Right? And again, so what this means? This means so you want a diversity of goods. Like here, you have a lot of C, you want more C. Here you have a lot of C prime, you want more C. So your willingness to pay for C is very high. And now here, so you have lots of C, you have lots of C, you have very little C prime. Your willingness to pay for C is low. That is inversely means your willingness to pay for C prime is very high. So that's what it means. You prefer diversity, and this diversity means the curve have a smaller and a smaller slope. So that means this is a convex curve. Okay, so this is regarding second. Now the third one, it just says C and C prime both are normal goods. So that just means if your income increase, the curve is going to shift up, or you are going to move from this curve to the other curve when you have a higher income. Okay, so that's coming from the assumption regarding to preference, right? Okay, here just summarize what I just discussed. Right? The intertemporal marginal rate of substitution, usually MRS, is the rate at which consumers are willing to substitute C for C prime. Okay, so this is a willingness to C for C prime. You substitute C, you substitute 1 C, like in the previous case, at point B, if you give up 1 C, you must give me 3 C prime at B, right? At point A, you give out 1 C, and then so you only need to give me 0.5 C prime. And then clearly you can see, so B, you cares more about C, but A cares less about C, right? So this is what is marginal rate of substitution means and what these measures. Okay. So the intertemporal marginal rate of substitution, or MR, is measuring willingness to substitute consumption over time, like today and tomorrow. And finally, it decreases with current consumption, right? Meaning, so you are more willing to substitute. You're more willing to substitute, right? Right. So now we have to understand consumers' preference, which is characterized by U of C and C prime. Right. So actually, this is a consumer's objective. As we're going to see later, consumer is trying to maximize this utility function. Right. But usually, so people are subject to a constraint. So now let's see what kind of constraint we are subject to in this model. In the current period or in the first period, the consumer has a budget constraint as follows. C is consumption today. S is saving. Y is what we already described, their income. And T is the tax the household must pay. Right? Everyone needs to pay tax. Okay, so this is the first period. Now look at the second period. In the second period or in the future period, on the left-hand side, you only have C prime. You feel free to write S prime, which is saving. But because the second period is end of period, there's no third period. So saving equal to 0 because there's no point for the save. Right? Now on the right-hand side, similarly, you have income. Y prime, you pay tax. But now this is a new term. What is this new term? This is a saving from the first period times interest rate, right? 1 plus R. So 1 is what is saved, R is the interest rate. So like 1 is like a principal and R is the interest. Okay, so this is your income in the second period, right? So actually we can combine them together, right? So the way we combine them together, maybe just go back to here, and so make sure we understand. Make sure we understand how we get things done. Let's just copy the first one. C plus S equal to Y minus T. Now our goal is just cancel this S, right? So what are we going to do? So we are going to multiply by 1 plus R. Okay, 1 plus R and 1 plus R. All right, and then add them together. So these two equations, you add them together. And hence, this is going to cancel with this, right? And then left-hand side, we end up with 1 plus R times C plus C prime equal to 1 plus R times Y minus T plus Y prime minus T prime. But alternatively, we can say C plus C prime divided by 1 plus R equal to Y minus T plus Y prime minus T prime over 1 plus R. So these two are equivalent. So how we move from equation 1 to equation 2? We simply divide both sides by 1 plus R. That's how we get, right? So now go to the next slide. So actually we end up with this equation. Okay. But let's see, so how we interpret this equation. The key to understand this equation is to understand this term. 1 plus 1, 1 over 1 plus R. This is a relative price of future consumption. How we understand that? If you have $1, all right, and then you save this thought with this $1 is going to become 1 plus R dollar. All right, let's say for example, so you can use this $1 to buy some goods, say for example, water. And with $1, you can, for today, you can buy 1 bottle of water. That's 1 bottle of water today. But if you decide to postpone your consumption, you save this money. And then, so in the future, you're going to use this number, you are going to use this dollar to buy the bottled water. Okay, assume there's no price change. And then that just means in the tomorrow, how much water is you're going to buy? You're going to get 1 plus R, right? So you're going to get 1 plus R. Okay, 1 plus R bottle. water. But remember, so this is the same amount of money. You either buy today or tomorrow. That just means these two must give you the same value, or just cost you the same amount of money in today's term. But that immediately implies tomorrow's bottled water is cheaper, because one bottle of water today is equal to 1 plus R bottle water tomorrow. That immediately means the price of the future bottled water is going to be 1 over 1 plus R. So that's how we end up with here. This is a related price. Now we understand that. Look at left-hand side. Left-hand side is the total consumption, C over C prime over 1 plus R, right? So this is just in terms of today's price. Similar on the right-hand side, this is your current income. This is your future income. But then your future income converted into today's price is most of the times the price, right? So that's how we understand this equation. To summarize, this equation says this in terms of today's price. So your total consumption cannot or must equal to your total income, right? So this total income in terms of the price of today. Right, so if we defined the right-hand side as WE, this WE is wealth. Okay, this stands for wealth, and this is lifetime wealth, right? So this is your current wealth and plus your future wealth, but then so multiply the price. Okay, so in terms of today's price. Okay, so that's going to give you the lifetime wealth of the consumer. And then so we can rewrite this equation as following, right? This is simple algebra. But finally, we do some manipulation, right? So we end up with the C prime equal to this, right? And then essentially, this just says C prime as a function of C. Okay, so this is going to be very useful for us to analyze. Why? Remember, when we have the indifference curve, we have C and C prime, right? Or in other words, C is a function of C prime, the function of C. So that's going to help us for our future analysis. So that's why we end up with this. So that's why we end up with this equation. But again, so this equation is just simple algebra based on the earlier equation, right? Now we are ready to put the consumer's lifetime budget constraint, which is the equation here, into a diagram. Remember, this is C prime as a function of C. Is C prime as a function of C. If we inspect this equation, then clearly you can see the slope of this. By the way, this is a straight line, right? Because this is a linear relationship between C prime and C. The slope equal to -1 plus R, meaning so this is a downward slope line. This is number one. Number two, the interception on the y-axis must equal to 0 and 1 plus R, right? So this is when C equal to 0. On the other hand, the interception on x-axis, this is when C prime equals 0. Okay, it shouldn't be difficult for us to find out. It's going to be C equal to WE and C prime equal to 0. All right. Now let's go to here. So that's exactly what we have. First, the slope. This is like a downward slope. The slope of the curve equal to -1 plus R. Right. Let's go back here. Right. -1 plus R. And the interception. So on the x-axis, it's going to be WE and 0. And how we understand that? That just says if you devote all your wealth into consumption today, so that's all you can consume, you're going to give up future consumption. Now, vertical line or y-axis, interception is going to be 0 and WE times 1 plus R. And now here we go to the opposite. You give up today's consumption, and then you are going to wait for future to come and consume everything you can. Okay, so that's going to be different. That's going to be different, right? So this is what you can consume if you postpone all of your consumption. And in the middle, we have a point we call E. Actually, this E stands for endowment, meaning this is what you were given. Right? And then what you are given. So this is what you're given today and then tomorrow. Today, if you just spend all your, so today you have income minus tax. That's your disposable income. Okay, this is your disposable income. Similarly, tomorrow you have Y prime and a T prime, right? So it's also your disposable income, right? So now, furthermore, we can divide this budget line into two regions. If you are here, if you're in this region, you are considered as a lender. Why? If you are in this region, and then so you consume, so this is because this region, this is what you're going to consume, right? So you're going to consume less than what you have today, but you're going to consume, you're going to consume more than you have tomorrow. So that means you're going to save for today, and how you're going to save, you're going to lend it out. So that's why it's called a lender. And similarly, so if we look at the other part, if you're in this region, then you're a borrower. Why a borrower? So today you're gonna consume more than you have, and not for tomorrow you're gonna consume less than you have. That means you're gonna save today and for future. Oh, sorry. And here, so you consume more than you have today, right? So in order to find those extra consumption, because this is your income, you must borrow. And you borrow from future, essentially. Because in future, you must pay. You borrow from your future. Hence, future, you're going to spend, you are able to consume less than you have in the future, right? So because you pay off your debt, right? So now we can bring these two things together to understand consumers' consumption and saving decision. Okay? Where we start with indifferent curve, right? And then so we have this budget constraint, right? So everything the household is trying to do, if we just extend this budget constraint, right? What this budget constraint tells us, everything inside is feasible, everything outside is infeasible. Everything along this line is the best. Okay. Now, what is consumer's consumption and saving decision? So the consumer, given this straight line, they are going to move this indifference curve further away from origin as possible as they can. Remember, we have three properties regarding to indifference curve, or regarding to the household's preference, right? The last one, so both are normal goods. And the first one, so you get, so more is always preferred to less, right? So hence the consumer trying to do is just move this curve away from the origin. If the more, so it is further away from the origin, usually it just means higher level of indifference curve, or higher level of utility, or higher level of happiness, right? But then the households must be subject to this budget constraint. So this is what's going to happen, right? Now let's just look at this table to understand what do we mean consumption smoothing. Right? There are three scenarios for Sarah. So in each of those three scenarios, the total consumption is the same. But usually the individual may prefer a bundle like this, right? But what's the difference between this bundle and with the bundle here, or bundle 1 or 2? So bundle 1 and bundle 2, so they have either go to the extreme of focus on week 1 or focus on week 2. But then, so the preferred bundle has a right balance between week 1 and week 2. Okay, so that's what I mean consumption smoothing. But this consumption smoothing also reflects the preference to diversity, right? Now we can understand, now we are ready to look at households optimization problem. So the main result is as follows. If the households have optimized or reached optimal, And then the following condition must hold. This condition says the market rate of substitution between C and C prime equal to 1 plus R. What is on the right-hand side? That's 1 unit of C in the exchange of 1 plus R unit of C prime. Or in other words, in the market, you can change or you can buy, you can sell 1 unit of C, and as exchange, you get 1 plus R unit of C prime. And for the households, their preference is given by MRS C prime, meaning so the households willing to exchange 1 C for MRS unit of C prime. Okay. And this optimization problem is going to characterized by here. This straight line, like I said, this is a budget constraint. Everything inside is not optimal. Everything outside is infeasible. So you must go along this line. But then, so the households is going to choose consumption bundle such that so they are going to achieve the highest level in different curve. And then the optimal is going to show up as this curve, this I curve tangent with this straight line. And here, so you have MR is equal to 1 plus R. Okay, C prime. Now let's see what this means and why this is the case. So if example, you have a point here, or you have a point here. Let's start with this one. Okay, let's start this one. At this point, right? As a matter of fact, you're probably going to have indifference curve like this. But from the graph, you already seen. So this indifference curve is going lower. But now let's see so how you can improve if you are here. If you are here, okay, you have marginal rate of substitution like this, or in other words, if you are here, you have your marginal rate of substitution between C and C prime is greater than 1 plus R. What this means here, you are willing to substitute C for C prime, at a much higher rate compared to market. Let's just put some number. Okay, so for example, this number on the right-hand side is 1.1. On the left-hand side is 1.5. And then, so here in this point, they just says, I'm willing to give up 1.5 unit C prime to get 1 unit of C. But in the market, actually, I can buy C at 1.1. Meaning, so if I just increase my consumption today, okay, and give up consumption tomorrow, actually I'm going to improve, right? Because again, so this is what I need to pay in the market. This is what I'm going to value, see myself. Okay, so my benefit exceeds my cost. So hence, it's better when we move to this direction. Alternatively, if you are here, and then so you have a marginal rate substitution like this, it's going to smaller than 1.1. Or in other words, here, because you have lots of C, I only willing to give up 0.8 unit of C prime to get 1 C. And now here, it's probably better for you to reduce your consumption today. You're going to sell your consumption. By selling my consumption, okay, so what I'm going to lose, I lose 0.8 unit of C prime. So that's, to me, that's a value. Because 1 unit of consumption C is equivalent to 0.8 unit of C prime and here. Because I will already have a lot of C. But in the market is going to reward me with 1.1 unit of C prime. So this is my cost, this is my benefit. And here, so you are better just go to this direction. All right. To summarize, either you are in this side or you are in this side. You can improve. If you are on the left-hand side of this point, it's better to increase consumption today. If you're on the right-hand side of these dots, you better to decrease the consumption today. Only when you reach here, your evaluation between C and C prime is exactly the same as what the market is willing to pay, willing to exchange for you, right? So there's no way for you to improve. There's no way to improve. Hence, we are in the equilibrium, or hence you reach the optimum, right? Now let's consider two possibilities to see what that means to each individual. Okay? So number one, you may have endowment here, and your choice is going to be here. So that means you want to consume more than you have today. The way you can do that is you must borrow, right? So you borrow more. So this is your borrowing. But in the future, you must pay, and this is what you have to pay. Okay, so this is when you are borrower, means you have very little endowment in the first period, but you have a lot of endowment in the future period. All right, and then so you willing to borrow, and then future you have to pay. Right, so the borrow amount increases C. Oh, sorry. And alternatively, you may have someone here. So we means it's going to be a lender, right? It's going to be a lender, meaning so if you have endowment here, this is your endowment, right? And then so today your endowment is more than you choose to consume. So this is going to be your saving, and this is going to be your right. So in the future, that's your interest income plus your principal, right? But in either case, whether you are a borrower or you are a lender or saver, right? Now, what we found out is your optimal choice is going to be the same. It's going to be the same. But however, depending on whether you are a borrower or saver, your saving decision is going to be different. Yes, your consumption decision is going to be the same, but your saving decision is going to be different. If you are a borrower, and then your saving is going to be negative, meaning you borrow. If you are a saver, and then your saving decision is positive, meaning you save. Right? This is summarized right here. Okay. So first, so we have consumption smoothing. The household's ability to borrow or lend create trade-off between current and future consumption. Now, your current and future consumption will only depend on your lifetime wealth, but not its competition. So competition means your position. Let's go back here. So competition means so where you are, either here or here. But as a matter of fact, in this example, your optimal consumption is only determined by this line. It doesn't matter which point you are along this line. You either here or here, you can end up with the same consumption bundle. But certainly these results may not hold or may not survive when we have some frictions in the economy. Right. Now, second point, saving decision, it does depend on competition of lifetime wealth. Okay, if you have a lot of first period income, you're more likely to be a saver. If you have a lot of second period income, you're more likely to be a borrower, right? So you're going to use future income to finance your current consumption. Like I just said, so these results may not survive. And to make sure these results survive, we have a big assumption. This is the saving market, borrowing market, or in general, we call it financial market. Financial market work perfectly, no friction. You get what you need, meaning so you can borrow as much as you wish. You save as much as you like, right? So, and then the saving rate, borrowing rate, the same, which is reflected back here. So the curve is straight line. So if you are here, you borrow at the rate of 1 plus R. And here you save at the rate of 1 plus R. Okay, so the financial market is perfect. Saving and lending market is just perfect, right? So you just freely get what you need. You just freely save what you don't need, and you get the same rate. Okay, so this is more perfect. But we are going to see later this in this chapter. So this may not survive. This result is going to change when there is some friction or when the market is not perfect as we wished, right? So now let's see. Now that we can use this model to understand some interesting phenomena. First, what happens if there's increase in current period income, right? Example. So what is current period income? This is like usually we should say this is like a temporary increase, right? So what is the example? If you win a lottery, okay, you win the lottery, okay? And so this win a lottery, it comes one time. You cannot expect this is going to come. This is going to come frequently, right? Okay. So now you are going to react, and usually you're going to react by smooth your consumption over time, right? First, your current and future consumption is going to increase. Why? Because your lifetime wealth will increase. But secondly, your saving is going to increase. Why is that? Why is that? Your saving increase is because so this is a one-time increase in income. You don't want to spend all of this lottery. You want to save for a little bit for future, so that future you also increase. To be precise, saving increase because increase in consumption is smaller than increase in income. Your income increase is going to distribute between consumption in the current period and the consumption in the future period. That's how you're going to distribute your income increase. Okay, you want, because you care about C today and C tomorrow, right? So now here, this is a graph. Now this is a graph. We start with this budget constraint. You have lifetime wealth or lifetime wealth. Now you win a lottery, and then your lifetime wealth increases here. When we start, we are here. We had A. When we end up with B. Right? So clearly, both C and C prime increase, right? C increase from C1 to C2, and C prime increase from C1 prime to C2 prime, right? So both increase, okay? But then in terms of C increase, right? C increase. So the C increase is less than, so this is a C increase, right? So if you go here, so from here to here, so this is horizontal difference. C increase is less than your income increase because your income increase from here to here. Why? Is because the income increase, you must distribute between C and C prime because you cares about C and C prime. Okay, you want to spread out your consumption, right? So this is how an increase in current income, how a current income leads to a change in terms of your consumption and saving decision. Another thing I want to highlight is, let me erase here. If you look at this E point, oh, by the way, so this is when you start with your endowment. This is after you win a lottery, your endowment increase, but there's nothing changed for your second period. Right now here, right? So you are a saver, right? But now, like I said, so this is your saving. Now look at it here at the end. So you go to here, right? Then this is your saving. This is a new saving. And clearly your saving increase. Right? Okay, so why you want to save more is because you also care about future consumption. Right. So now let's see what happened in the data. Okay, so in the data, what we found is the aggregate consumption of non-durable goods is smooth related to aggregate income. But the consumption of durable is more volatile. So here we differentiate between non-durable and durable. But what's the difference between non-durable and durable? And how we differentiate between non-durable and durable? So durable is something lasts for a while. So for example, so you have a car, this is durable goods, or sometimes you can even call this like investment, right? In a house, some like appliance, like say for example, your dishwasher or washing machine. So those are durable. So this is going to last for a while. What's non-durable? Like daily staples, right? Food and beverage. Those things are non-durable. So it means you're going to frequently consume, and this you're going to frequently add more consumption on that. right? In the data, what we find out is the non-durable goods consumption is fairly smooth, even though if you have a fluctuation in your income. But your durable consumption is very volatile when there's a fluctuation in income. The reason why is because the durable goods is like investment, right? So you can postpone your investment, but for non-durable goods, they are essential. You cannot, and you care more about their smoothing. So that's the reason. So actually, we can look at the data. So this is the US data in the middle. This light blue line is GDP, which is income, right? We can interpret this as income. The dark line, the dark line, the solid dark line is consumption of durable goods, right? And this is a percentage deviation from trend, or essentially, simply you can consider this as how it is compared with the previous year. Okay? And clearly you can see that non-durable goods fluctuate more than your income. Overall, when income increase, it increase more. When income decrease, it decrease in a much larger magnitude. Now, if we look at non-durable goods, okay, again, this is GDP, and this is interpreted as income. And this dark line, this is non-durable goods. And you can see this non-durable goods, yes, also fluctuate, right? Whenever income decrease, it's going to decrease. Whenever income increase, it's going to, this is income. Whenever income increase, the non-durable goods consumption also increase, right? Yes, it is true. But however, so the magnitude of the fluctuation is much smaller. It's much smaller. This is consistent true throughout the time period we look at after World War II till 2010. Right? So this reflects the consumption smoothing for the households. Now let's look at another possibility. If there's an increase in future income, what are you going to do? To summarize, if there's an increase in current income, usually you're going to consume more for today and tomorrow. And you're going to save, right? You're going to save a fraction of your increase in current income so that you can have more consumption in the future. So this reflects the consumption smoothing. Now, what happens if there's an increase in future income? Example could be if you decide to change your major. You change your major from philosophy for business. Right? Usually, so the business major, the college students, so they are going to make more compared to someone who has a degree in philosophy. But certainly, there's a reason why people choose to study philosophy, right? Besides this monetary compensation, you may have other preference, or you may develop other utility from studying this abstract concept, right? Okay, so C and C prime, they will only depend on lifetime wealth, not its composition, right? Hence, the effect of increase is the same as here, or it's largely the same like we had before, right? C and C prime is going to increase. C and C prime increase, right? Because your lifetime wealth increase. Right? But now the interesting part is your savings is going to decrease. Why savings is going to decrease? Because the income increase coming from future, right? And then you're going to want to smooth your consumption. You want to allocate part of your future income increase from future to today. How you can do that? You either reduce your saving or you increase your borrowing depending on your initial endowment, right? Let's look at this example. Look here. Okay. So this is where we start with WE, and then you have WE prime, WE prime. Okay. So clearly, so you have more income in the future, right? So now your consumption is going to move from here to here. All right. And as a matter of fact, so you can consider this is your endowment point. This is the endowment point, right? So actually, so maybe to simplify, so endowment we start from here, just coincide with what we consume. Now your endowment goes to here, and then so this is your total increase your income. But this is what you're going to increase in your consumption, and this is what you save. But this is saved in the future. But then this saved in the future is going to go back here. This is going to go back here. And you're going to increase the consumption. Okay, and so you're increasing consumption today coming from where? Coming from future. And essentially you just borrow from future. Right? How we understand you borrow from future? It's because before income increase, you consume what you have. Now you consume more than you have. So this is borrow. How you can borrow? This is because in the future, right? So this is what you consume, but this is what you have. And then the difference is what you have extra. And then so you're going to shift to today. The way you shift to today is today you're going to borrow, and in the future you're going to pay off. You're going to pay back. All right, so this is how increase in future income affects your consumption. Now we go to the third example. This is a little bit more complex, right? So we're going to study what happens if there's increase in real interest rate. Right? If there's an increase in real interest rate, there's going to have two impacts. The first impact is going to be a substitution effect. How do you understand that? Remember, this is a related price. This is a related price of C prime. If R increase, this leads to 1 over 1 plus R is going to decrease. Meaning C prime is getting cheaper. If C prime getting cheaper, what are you going to do? You're going to substitute C prime for C. Meaning you're going to increase C prime, you're going to decrease C. So this is called substitution effect. But at the same time, there's a Wells effect. Where is the Wells effect? So this is left-hand Wells. That is left-hand Wells. Okay. And so this is left-hand Wells in terms of current. And this is left-hand Wells in terms of future. Right? But certainly depending on who you are lender or borrower, right? And then if a lender or borrower, it's going to have different impact. But for now, so basically this means increase in R is going to decrease your current wealth, but it's going to increase your future wealth. But remember, so we talk about two extreme cases, right? So if you just go to here, if we only care about today's consumption, and then this is wealth. This is your total wealth. If you only care about future consumption, and then this is your total wealth in the future, or how much you can consume in the future. So now R increase, if you just only care about today, that means this is going to decline. If you only care about future, this is going to increase, right? So it's clearly, so it's depending on where you are, who you ask, all right? But in any case, there are two effects when there's increase in interest rate. Let's go back. Right? First, there's a substitution effect. Right? The substitution effect says increase in interest rate is going to lead to a decrease in C today, but increase in C prime in the future. Okay. On the other hand, there's a Wells effect. Right? But the Wells effect is going to depend on who you are. Now let's use a diagram to explain. So why it depends on who you are. Right? Okay. So this is where we start. This line, this is where we start. Now R increase from R0 to R1. So the curve gets steeper. So now you're going to have this new budget constraint with this dotted line. And then clearly, so if you're a borrower, you go to right hand side of this endowment. And clearly see, so the curve is going to push down. Right? So the borrower is going to become poorer, but it's also intuitive because borrower, because high interest rate, they must pay more for the interest. Right? On the other hand, the lender, they can become richer. The curve is pushed up. This is also intuitive. High interest rate is going to bring them more interest income. They become richer. Right? But then if it's a lender or saver, so the income effect leads to C and the C prime increase. If the borrower is going to lead C and the C prime decrease. So this is for income effect. But we need to combine with substitution effect. Now here summarize. Okay, if the lender C and C prime increase, borrower C decrease and C prime decrease. Substitution effect, C is going to decrease, C prime is going to increase. Right here, so this C increase and C prime increase, and C decrease, and C prime decrease. Hence, net effect really dependent on who you are. Right? If you're a lender, and then we are going to combine these two. Right? So clearly, if you're a lender, let me write down here, lender. If you're a lender, and C, we don't know, but C prime is going to increase. If you're a borrower, and then so we are going to combine this with this. What do we know? If a borrower, C prime is going to decrease. Sorry, C is going to decrease. C prime is not clear because one leads to increase, the other leads to decrease. Right? To summarize, an increase in market real interest rate has two effects on your consumption saving decision. Right? One is the substitution effect, the other is wealth effect. This is number one. Number two, the net effect is going to depend on who you are. Are you a lender or a borrower? Right? If you're a lender, for sure it's going to increase your future consumption, but it's not clear about your current consumption. That depending on which effect dominates. If you're a borrower, and then for sure you're going to reduce current consumption. Regarding the future consumption, it's not clear. Again, it's going to depend on it is going to depend on which effect dominates. The demand is income effect or substitution effect. Right? Now in this diagram, we show two possibilities. On the left-hand side is a lender. On the right-hand side is a borrower. Let's start with lender and see how a change in interest rate affects the consumer's consumption and saving decision. Or we start with here, right? We end up with this one, right? So this curve is getting steeper. Okay? When you start with WE, okay? And A is your optimal choice. This is optimal choice. This is when you start with E. Now, if there's a increase in interest rate, so there are two effects, right? So first, we move from A to B. So here you have this dotted line. So what is particular about this dotted line? So this dotted line, let me write down. There are two things. Number one, same slope as WE1, meaning so you have the higher interest rate or R1. Okay, number one. Number two, so this dotted line is going to keep the IC. So in that sense, so this is the way the way we rule out or we separate the wealth effect, or right now, separate wealth effect. We separate that. So this is the purpose of this dotted line, meaning so the dotted line tangent with the indifference curve, the original indifference curve. You have a new consumption bundle B, and A to B, that is a pure substitution effect. And why is pure substitution effect? Because we separate wealth effect, because we stick with the same IC or IC0. And the same at the meantime, so you include the interest rate or the substitution effect, which is we include R1 because the curve gets steep, the budget line is getting steeper, right? A to B is a substitution effect, right? And how substitution effect show up? Because the interest rate increase, the future goods becomes relatively cheaper, and then you're going to increase C prime, you're going to reduce C. Hence, you move from A to B. So A to B, that's the substitution effect. Now, we are going to move from this dotted line to the final budget constraint. Now, the difference between this dotted line and the final budget constraint is that the level is higher. The level is higher. And this level, the higher level is just pure Wells effect. Because from the dotted line to this solid line, there's no change in slope, no change in interest rate. Hence, from B to D, that is a pure income effect. Okay, with pure income effect, you can see so both C and C prime is going to increase. Both C and C prime is going to increase. Right. So this is a lender, right? Remember, because the lender, right? So they have higher net wealth in the future, right? So that's what they care is a lender, right? Because this is the endowment point. So they are going to consume on the left-hand side of the endowment curve. Right? This is for lender. Right, so let's erase and then just look at right-hand side. And similarly, right-hand side, we start with A. We start with A. Okay. Now, we are going to draw a dashed line. This dashed line is going to tangent with the same indefinite curve. We're going to get a B. So from A to B, as before, this is substitution effect, the same. C is going to decrease. C prime is going to increase because future goods becomes relatively cheaper. Now, from this dotted line to this solid line, that's a pure income effect. So now you move from B to D. From B to D, because this is a borrower, right? So he's consumed more than he has endowed, right? So the borrower, so they have negative income effect. So hence, look at here from let's see, from B to D, from B to D. So you can see both C and C prime is going to decrease because there's a negative income effect for borrower. Right? To summarize, so in this graph, we studied how we decompose substitution effect and the income effect. This is number one. Number two, we also separate lender versus borrower. Their positions different in terms of this line. Either you are this region or you are in this region. And the implication to them is different because borrower, the income effect is negative. For lender, the income effect is positive. Right? So this is how we decompose the impact of interest rate change on consumption and saving decision. Right? Here is just summarize. Right? For lender, okay. So for the lender, you're going to have clear cut in terms of future consumption, but you don't know what's happened to current consumption, and furthermore, or currently you don't know what's going to be current saving. For borrower, and then clearly you're going to reduce your consumption, current consumption. That should lead to increase in current saving. Right. So this is how changing interest rate affects the consumption and saving decision. And we also do a decomposition. Now we are looking at a particular example. So this is a perfect complement, right? So what is perfect complement? And essentially here we say the consumer, this is what they are going to choose in equilibrium. But this is not but yes, this is a preference, okay? But this is a preference. But this preference is coming from a utility function, right? But this is implicit preference. So the actual preference usually is coming like minimum C and C, right? C and C prime. I believe A, something like that. All right. Okay. In any case, so this equation just tells you how consumer is going to allocate C and C prime. So this is just going to tell you how they are going to do their optimization or how they choose their optimal bundle. Right? And then similar like before, the budget constraint is the same. The budget constraint is the same, right? But from these two, we already able to solve the consumer's consumption and the saving decision, right? Why? Because there's two equations, right? But we only have two unknowns, two equations, two unknown, and immediately we can solve the consumption and the saving decision. So this is consumption, right? This is consumption today and the consumption tomorrow. But from here, we can solve the saving. Remember, C plus S equal to Y minus T. But clearly, so WE here is equal to Y minus T plus Y prime minus T prime divided 1 plus R. Right? And here, so once you know C and you just plug in this equation, you get S. Right? Right, actually, so here we just substitute the left-hand wells. Right? And then so we just write C and C prime explicitly in terms of Y. There are following things: Y, T, Y prime, T prime. And the other things R and A. R is interest rate. A actually is characterized how consumer choose consumption and saving decision. So this is how we solve this model, right? Actually, so this is how the preference look like. So this is a preference, right? So this preference is called perfect complement. How we understand this perfect complement? So if you have this amount of C, you increase your C prime, regardless how you increase the C prime, it's not going to change your consumption. Right? This is like example is like if you just consider this is your left hand side shoes versus your right hand side shoes. If you have one left hand side shoes, okay, and once I have one right hand side shoes, that's giving me a certain amount of preference or utility. Regardless how many right hand side shoes you're going to give to me, it's not going to change my utility. So this is captured by this part. Similarly, so if you give me one right-hand side shoes, and regardless of how many left-hand side shoes you give to me, it's not going to change my utility, right? So this is called perfect complement, right? These perfect complements is help us to simply solve the optimization problem, right? Because the optimal consumption bundle must satisfy this, and also must subject to this budget constraint. Hence, this equation plus budget constraint is going to join to solve C and C prime, as we just showed. Right? Now here we just finish the first half of this chapter. Right? To summarize what we did, we have a consumption and saving decision model to study how consumer choose their saving and consumption and decision. And then we also study how consumer is going to respond to change in current income, future income, and interest rate. In the second half, we are going to study how consumer is going to respond to change to government policy. And this model is also going to help us to understand some government policy issue, like government debt.